Article 334.10b of the National Electrical Code addresses terminations and splices for non-metallic sheathed cable, specifically type NM. The code mandates that insulation be stripped back only a sufficient length to facilitate proper connections, with a maximum allowance of 1/2 inch or 13 mm. Furthermore, it explicitly states that approved splicing devices must be employed when connecting two lengths of cable. It is crucial to note that splices are strictly prohibited from being located within panel boards, junction boxes, outlet boxes, or any other concealed locations. This requirement ensures accessibility for inspection and maintenance, and prevents potential hazards that could arise from concealed connections. The core principle behind these regulations is to maintain the integrity and safety of electrical systems. Using listed or approved products as directed is a fundamental aspect of electrical work, as emphasized in Section 110.3b. This means that all materials and equipment used in electrical installations must be evaluated and certified by a recognized testing laboratory, such as Underwriters Laboratories, or all. The listing indicates that the product has been tested and meets specific safety standards for its intended use. When working with metal-clad cable or armored cable, commonly referred to as MC or AC cable, it's important to understand the specific requirements and limitations associated with these types of wiring methods. Improper handling, such as using tools not designed for the purpose, can compromise the cable's integrity and create potential hazards. While the provided extract directly references non-metallic sheathed cable, the underlying principle of using listed products as directed applies universally to all wiring methods, including MC and AC cable. The code emphasizes adherence to manufacturer's instructions and the use of appropriate tools and techniques for each specific cable type. This ensures that the installation maintains its intended level of safety and performance. Now, let's delve into why using tools like tin snips or dikes on MC or AC cable is generally discouraged and often prohibited by code and best practices. Firstly, MC and AC cables have a metallic sheath that provides mechanical protection to the conductors inside. This sheath is designed to be robust and resistant to damage. However, using inappropriate tools like tin snips or dikes can easily damage the sheath, creating sharp edges or weakening its structural integrity. Secondly, damage to the metallic sheath can compromise the grounding path of the cable. The sheath is intended to provide a low impedance path for fault currents to return to the source, which is crucial for proper operation of current protection devices like circuit breakers or fuses. If the sheath is damaged or compromised, the grounding path may be impaired, increasing the risk of electrical shock or fire. Thirdly, tin snips and dikes are not designed to create a clean, controlled cut on MC or AC cable. These tools tend to crush or deform the metallic sheath, rather than cutting it cleanly. This can result in exposed conductors, sharp edges, and difficulty in making proper connections. The result is a non-compliant installation that is unsafe. Fourthly, the National Electrical Code requires that all electrical work be performed in a neat and workmanlike manner. Using appropriate tools and techniques is essential for achieving this standard. Improperly cut or terminated MC or AC cable is a clear indication of substandard workmanship and can result in rejection by electrical inspectors. Fifthly, many manufacturers of MC and AC cable offer specific tools and accessories designed for cutting and terminating their product. These tools are engineered to create clean, precise cuts and to ensure proper grounding and bonding. Using these specialized tools is not only recommended but often required to maintain the cable's listing and warranty. This means that the product is tested to the requirements of UL. Failure to use the right tool means the product no longer meets the requirements. For example, Roto splitters, also known as spiral cutting tools, are commonly used for removing the outer jacket of MC and AC cable. These tools create a spiral cut along the jacket, allowing it to be easily removed without damaging the conductors inside. Roto splitters typically have adjustable blades to accommodate different cable sizes and are designed to provide a clean, controlled cut. In contrast, tin snips or dikes are more likely to damage the cable and create a hazardous situation. When using a roto splitter, it is crucial to follow the manufacturer's instructions carefully. This includes selecting the correct blade depth, maintaining a consistent cutting speed, and ensuring that the tool is properly aligned with the cable. Failure to follow these instructions can result in damage to the cable or injury to the user. In addition to roto splitters, other specialized tools are available for working with MC and AC cable. These include cable benders, cable strippers, and cable termination tools. Each tool is designed for a specific purpose and can help to ensure that the installation is performed safely and efficiently. The importance of using listed or approved products as directed by the manufacturer cannot be overstated. Electrical codes and standards are in place to protect people and property from electrical hazards. Failure to comply with these codes can result in serious injury, death, or property damage. It is the responsibility of all electrical workers to be familiar with the applicable codes and standards and to follow them diligently. Firstly, always ensure that all materials and equipment used in electrical installations are listed or approved by a recognized testing laboratory. Secondly, carefully read and follow the manufacturer's instructions for all products used. Thirdly, use appropriate tools and techniques for each specific task. Fourthly, never compromise on safety. If you are unsure about any aspect of an electrical installation, consult with a qualified electrician or electrical inspector. Fifthly, proper grounding and bonding are essential for electrical safety. Make sure that all grounding and bonding connections are made correctly and that they are properly sized for the application. Sixthly, protect conductors from damage. Avoid bending cables too sharply or exposing them to excessive heat or moisture. Seventhly, support cables properly. Use cable ties, clamps, or other approved methods to support cables at regular intervals. Eighthly, seal all openings in electrical boxes and enclosures to prevent the entry of moisture, dust, or pests. Ninthly, label all circuits clearly. Use circuit directories or other labeling methods to identify the purpose of each circuit. Tenthly, inspect all electrical work regularly. Look for signs of damage, wear, or corrosion and repair any problems promptly. In conclusion, proper handling and termination of MC and AC cable are essential for ensuring electrical safety and code compliance. Using appropriate tools, following manufacturer's instructions, and adhering to industry best practices are all critical for achieving a safe and reliable installation.